We're going to go over dividing radicals. And the one thing you need to know with dividing radicals, no radicals in the denominator. So we're going to have to simplify, and we're going to have to complete the perfect root to get them out of the denominator. So we'll start with problem number 1. Square root of 12 over the square root of 18. We're going to simplify, and we simplify this, and this becomes the square root of 2 over 3. Next step, we write it as separate radicals, so it's the square root of 2 over the square root of 3. Now what we do, we're going to actually multiply this by the square root of 3 to complete the perfect root. And if we do it to the denominator, we do it to the numerator. So now the square root of 3 times the square root of 3 comes out as 3, because it's actually the square root of 9, and the square root of 9 is 3. At the top, when we multiply the top, we get the square root of 2 times 3, which is 6 over the square root of 3. Final answer. Next, square root of 7 over the square root of 24. We simplify. We can't simplify the square root of 7. We definitely could actually break down the square root of 24 into 3 times 2 times 2 times 2. Notice that we have a pair of 2's. So anytime we have a pair, it can come out. So we're going to bring out, we'll write this 7, we're going to bring out the 2, and we will keep in the 3 times the 2. So I'm going to come back over here and write it again. The square root of 7 over 2 times the square root of 3 times 2. I need to get the radical out of the denominator. It's a square root. So what I need is, I need pairs. So I already have a 3, so I'm going to put a 3 over here, and I already have a 2, and I'm going to put a 2 here. At the top, I'm going to do the same thing, 3 times 2. Over here, on the bottom, I have a 2, and if I wrote everything under one radical, I have 3 times 2 times 3 times 2. Okay? So I have a pair. I have a pair of 3's, and I have a pair of 2's. So now that comes out. So now outside, I have a 2, I have a 3, and I have a 2. And at the top, over here, I have a 7, a 3, and a 2. So 7 times 3 is 21, and 21 times 2 is 42. And on the bottom, I have 2 times 3 is 6, and 6 times 2 is 12. So my final answer is square root of 42 over 12. Cannot have a radical in the denominator, and we don't, and we're done. All right, let's think through this one. What's wrong with this problem? Well, we have a fraction, we have a radical, and we have a radical in the denominator. Let's go ahead and see if we can simplify and separate. Can't simplify, so I'm going to write it as separate radicals. And so I have 25 at the top and the square root of 3b at the bottom. The problem is I have a radical under the denominator, so I need to get it out. So what I'm going to do is I'm going to multiply the bottom by the square root of 3b and the top by the square root of 3b. Awesome. I'm going to go ahead and give this one radical, and under the one radical is going to be 3b times 3b. And at the top, when I put everything under the radical, it's going to be 25 times 3b. All right. So at the top, what do I have? I have 5 times 5 times 3 times b. And at the bottom, since I have a pair of 3's and a pair of b's, it comes out as 3b. Okie dokie. So now at the top, I have a pair of 5's, so that will come out. And so this will be 5 times the square root of 3b all over 3b. Now, because this was an even root and an odd power, my final answer, 5 square roots of 3b over 3 absolute value of b. That's number 3. You can try number 4, show it to your teacher. And I'm going to do number 5. Number 5, cube root of 5 over 9. So this is a cube root, so we're going to separate it. Cube root of 5 over the cube root of 9. What's the problem? Radical in the denominator. How many sets do I need to come out? I need 3 sets to come out. So here, 9 is the same as 3 times 3. So what I'm going to do is I'm going to go ahead and erase this. Well, I'm going to try to erase it. And it's not working. So I'm going to write over it with another color. So 9 is the same as 3 times 3. Okay. So now I need a group of 3s to come out. So I already have 2. So I only need 1 here, and that'll be my third. And I'll do the same to the numerator. So over here now I have the cube root of 3 times 3 times 3. And at the top down I have the cube root of 5 times the cube root of 3. So on the top I get the cube root of 15. That can't be broken down anymore. And I have 3 groups of 3s. So it comes out like this. This is the final answer to number 4. Your turn. You're going to try number 4 and 6 and show it to the teacher. Thank you.